Hello everyone. What we're going to look at in this little short video is a solution to example 2L from chapter 7 section 2 of Ross's first course in probability. Okay? And what this section covers is expectations of sums, and also we looked at where we look at a bunch of different examples of how we can use this to simplify finding expectations of different random variables. Okay, so in this example, what we're going to look at is something called a random walk in the plane. Okay, let me just quickly read the example first. Consider a particle initially located at a given point in the plane and suppose that it undergoes a sequence of steps of fixed length, but in a completely random direction. Okay, now what that's saying specifically, suppose that the new position after each step is 1 unit of distance away from the previous position and at an angle of orientation from the previous position that's uniformly distributed over 0 to 2 pi. Compute the expected square of the distance from the origin after n steps. It doesn't say in the question, but when they're saying compute the distance from the origin, they mean the initial position. So you can say, let's start your walk at the origin. Okay? All right, so here we are. I've drawn a little picture to depict this. We're starting first at this origin, okay? And let's suppose first you pick some random angle theta 1, which happens to be this number that's, something between pi over 2 and pi. It's some specific number. And then you take a step of length 1 in that direction and end up at that orange dot. And then in the next step, pick another random angle between 0 and 2 pi. In this case, now theta 2 is some small acute angle. It's something between 0 and pi over 2. And you take a step in that direction of length 1. Once again, repeat, pick a random angle uniformly between 0 and 2 pi. And take a step of length 1 in that picked angle, in the direction of that picked angle. In this case, theta 3 is some angle in the fourth quadrant. Okay, so you can see all the time the angle that you're picking, of course, you're talking about the angle as it is with regards to the positive x-axis. Okay, so what is the segment? What angle does the segment make with the positive x-axis? That's the theta that you're picking. Okay, so what we want is to compute the expected square of the distance. Okay, so let's approach this problem. And what we will do is, we will say, let xi and yi be coordinates of the vector that is your ith step. So what do I mean? Let's suppose you are at some point at some time, and then you take a step. Then what you do is just add the xi, yi to the coordinates of this, and that will be your new position at time n plus 1, and this was at time n. Okay? So that's what I mean. So this is the coordinates of the vector representing the ith step. Okay. Now, let's call T. Let Tj be your position after j steps. Okay, so what is Tj? Of course, Tj is a point in the plane. So what will Tj be? Then Tj will be the first vector plus the second vector plus the third vector all the way till the jth vector, right? So the x coordinate will be x1 plus x2 plus xj. The y coordinate will be y1 plus y2 plus yj. Does this make sense? Okay, so in our example, what I have is this coordinate over here, that, whoops, sorry. This, in this example, this is T2. Okay, that, whatever be the coordinates of that point, that is T2. And of course, you have that the red dot over here, up here, that red dot, that represents T2. Oh, I'm sorry, I misspoke. This was T3. And that red dot represents T2. The orange dot represents T1. Black dot represents T0. That's your position after J steps. Okay, so I hope it's clear so far. And now we still need to relate what the theta I, xi and the yi's relation with the thetas are. Well, you know, just from your basic knowledge of polar coordinates, that what will xi be? Xi, that's the step, the change in the x that you get by taking a step in the direction of angle theta I, would have been r cosine theta I. R is 1 because the length of the jump is 1. So this will just be cosine theta I. Similarly, the vector position, the y-coordinate of the vector of the ith jump will be sine of theta I. Okay? All right. And what we want is, if d is the distance after n steps from the origin, we want to find what expected value of d squared is, okay? So let's say let d be the distance of the particle after n steps.
A message from Oviedo High School. A student in your household in grade 09 named Leah Swanson was absent on April 21st, 2021.
Sorry. I'm sorry about that. These are distance of the particle after n steps, okay? And I should say over here back, representing not your ith step, the particle's ith step. Oh, okay. All right. So we want the expected value of d squared. Well, what is d squared going to be? D squared is the distance of point Tn from origin. Right? Tn is where you are after n steps. So what will that be? It'll be x coordinate plus the y coordinate. Okay, so that's what we have. We want to find the expected value of this. So first, let's just do some little algebraic manipulations with that. What will this be? When you square it, you'll have a bunch of squares of the like terms, and then you'll have cross terms. And I'm just writing it as I not equal to j. If I do I less than j, then I'd have to put a 2 in there. Okay, and similarly for the y's. Okay, you got it? All right, and now let's take a look once again at what expected value of xi squared would be, okay, for any I. What will this be? Well, what is this? Actually, sorry, I don't mean that. Let's rearrange this for a second and write it as x1 squared plus y1 squared plus x2 squared plus y2 squared. And you will see in a second why I did that if you haven't already figured it out. Oops. Okay, so now take a look. What will expected value of xi squared plus yi squared be? Well, we know this is cosine squared theta I. That is your xi square, and this is sine square of theta I, or sine theta I square, whatever you want to write it as. Okay. So the expected value of this, but you know cosine squared plus sine squared is 1, so this will just be 1. Okay, that's nice, and you have a bunch of ones that you're adding up. Also, now let's look at expectation of xi, xj. What will that be? By independence, what do you have? Xi is cosine theta I, xj is cosine theta j. Now, if I is not equal to j, theta I and theta j are independent, so this expectation by independence will be the product of the expectations. We've seen that. You remember, this is by independence. Okay, and now what is expectation of cosine theta I? Well, we'll take a look at that for us. Take a look at that. So expected value of cosine theta I. What we're going to look at is, we will just use this formula. If you have a random variable, w, and you want the expected value of a function of w, you just integrate from minus infinity to infinity the function times the density. Let's just write a t for the variable we're using, times the density. Okay, that's the formula, right? I will just write down the general formula just so that you have it here. If you have a function of a random variable, what is its expectation? It's the function times the density of the random variable integrated. Okay, well, what is the density of theta? It is 1 over 2 pi when t is between 0 and 2 pi and 0 otherwise. Okay, so this integral will be 0 to 2 pi cosine t times 1 over 2 pi dt. Okay, and you know, well, that integral just turns out to be 0. Integral of cosine is sine, going from 0 to 2 pi, and so you get 0. Similarly, expectation of sine theta I for any I, you can work it out in the same way. This will turn out to be integral 0 to 2 pi, 1 over 2 pi sine t dt. This is also going to be 0. Okay, let's put it all together into the expectation of d squared. All right, so expectation of d squared was the expected value of x1 plus y1, x1 squared plus y1 squared plus x2 squared plus y2 squared plus xn squared plus yn squared plus sum I not equal to j x psi x j plus sum I not equal to j y I y j. Okay, put it all together. Expectation of sum is the sum of the expected values. Okay, and we've already seen each one of these is 1. Okay, and expectation of xi xj is the product of the expected values. And each one of these is 0. So what do you have? In the end, you have just added up n ones, so the answer is n. And so the expected value of the square of the distance from the origin after n steps is n. Okay, I will post this video, and I hope this made sense to you. All right, guys, thank you.